x to the x. All right. So when we write this out, this will be like a to the a minus x to the x all over a minus x. And we want to take a limit of this as a approaches x. And that limit will give us the derivative of x to the x. Okay, we're going to kind of proceed in the same basic way, thinking of these two boxes like this. All right, so it doesn't really matter which one we do. We could do a at the top or the bottom. We can go x to the a or a to the x, but we just got to have it different here in the middle somehow. So maybe we'll just do ax, but then we have to add a to the x, and then we're subtracting x to the x. And then we have this, so both of these are over a minus x. And then thinking about this switching property, notice how we have lots of a's. Let's limit how many a's we have. So this would be by switching. So we think x to the x minus x to the a all over x minus a. And then, of course, we could multiply top and bottom by -1. And taking a look at this now, in this case, let's just consider what's happening. So that's a, I guess. Sorry. Let's just switch that to a minus x. Okay, so this, what's going on with this? We could think, so x is a constant everywhere here. So if we want, so we don't not concentrating on so many x's, let's just call it c for a minute. So c to the a minus c to the c all over a minus c. So it looks like on the graph of c, so this a is changing to that c, right? So it looks like that's the graph of, or the curve of c to the x. Y is equal to c to the x, and the input is getting, so a in particular, the input, and maybe, let's let that be a c as well. Okay, so a is heading in close to c. So the input, what we're plugging into x, which is a, is getting close to c. So on the graph of c to the x, at the input value of c, we're looking at what the slope is. Okay? And that's actually what this limit computes to. That's what we're looking at. We're looking at the slope of the graph c to the x, y equals c to the x, at the input value of c. In other words, we're taking the derivative of c to the x and plugging in c. What is the derivative of c to the x? It's ln of c times c to the x, but we're going to plug in c. Boom. But what was c? It was x everywhere. So really, so what we've just computed, what this limits to, it limits to natural log of x times x to the x. Now let's take a look at this part. What is this doing over here? In a similar manner, you can think of c's as being everywhere. That might be useful. Let's see. And instead of a, let it be like the input of a function. So it's like we have, but let's write it out like that with c's first. So what's changing? This part is changing, the a to the c, right, as a goes to c. So that's kind of like a function x to the c, where we're looking at two input values, a and c, into it. And so as a approaches c, we're looking at, so if you have the graph of x to the c, however it looks, we're looking at, as we're heading in toward c, as a approaches c, what the input a is going to c, we're looking at the slope. So the slope of this curve at where we are plugging in c. What's the derivative of x to the c? Using the power rule, that's c x to the c minus 1. But we're plugging in c into that. So it should look, all right, like that. Okay, so it's c times x to the c minus 1. So we're plugging in c to that. So this should look like c times c to the c minus 1. Now what was c everywhere? It was x. So we should get x times x to the x minus 1. All right, So this part right here actually limited to that right here. And this part right here limited to that. So we end up, so this limits to this, and this limits to this, and so we get that the derivative overall of x to the x is just this plus this.